Hi, this is Adam Griffin, and this is going to be problem 29 for week 7 of the physics videos. So the question is, while driving to work last year, I was holding my coffee mug in my left hand while changing the CD with my right hand. The cell phone rang, so I placed the mug on the flat part of my dashboard. A deer ran out of the woods and onto the road right in front of me, but my reaction time was 0, and I was able to stop from a speed of 20 meters per second in 50 meters. So, and then later tests revealed that the coefficients of friction for the coffee mug are 0.5 and 0.3. And this one is for static friction, and this one is for kinetic friction. And the coffee mug has a mass of 0.5 kilograms. So we are trying to find out if the mug slid at all during that deceleration. So this problem is trying to get us to relate acceleration and velocity to friction. So what we want to do is figure out the acceleration as they slow down, and also what you would need for the coffee mug to actually slide. So we have our diagram right here where our initial velocity is 20 meters per second. And so we're going from 20 meters per second of v0 to our final velocity of 0 meters per second because we stop in 50 meters. So our acceleration, and this is the equation from the textbook for acceleration, we have our final velocity squared minus our initial velocity squared over 2 times the distance that it took us to stop. So we can plug that in for our distance, and we get 50 meters, right? Because it's right there. And then we have our final velocity, which is 0, and our initial. So it's just negative 20 meters per second squared. And we can plug those both in, and we get an acceleration of negative 4 meters per second squared if we are going at a constant deceleration. So that's our acceleration. And then we have, this is also from the textbook, where our coefficient of friction times gravity equals our acceleration. And that is this coefficient of friction. If it is more than our static friction, and we're looking at static friction because the mug is not already moving. If it's more than the coefficient for static friction of the mug, we know that the mug is not, or is going to slide, and if it's less, it will not slide. So we have the absolute value of acceleration because we have negative 4 meters per second squared, and if we plug that in as negative, we're going to have a negative coefficient of friction, which isn't possible. So acceleration equals our coefficient of friction times gravity, which means that our coefficient equals acceleration divided by gravity. So we can plug those in, where our exact value of acceleration is 4 meters per second divided by gravity, which is 9.8 meters per second squared. And that'll give us a coefficient of 0.408. So if our static friction is greater than 0.408, the mug will slide. But since it's, I apologize, this is supposed to be less than, but since it's greater, the mug will not slide. So that is how you do 29, and thank you.